everyone, I hope you're having an amazing day. So today we're going to talk about another design pattern, that is a facade pattern. It's a part of a structural design pattern. So you might wonder, why do we need a facade pattern, right? So think about a scenario, right? Let me give you a very classic example. Let's say I'm a brewery, like I run a brewery, right? So we ship beers to different customer, right? So the brewery has one purpose, to make beers, but that's the manufacturing side. But then we have to deal with the commercial side, where we ship our products. So let's say my company has a website, right? A nice looking website where a client can order stuff, right? They can order beer, they can add an items to the cart, and then check out and then pay, right? And then the items will get shipped. Nice and simple, right? Now think about from a software perspective, right? You have different subsystems, right? Let's say you have a subsystems called a product subsystem. A product subsystem. The purpose of the product subsystem is to check whether the item exists, right? And if then if an item exists, then add to the cart, right? And then whether the customer has entered the right item, so a different validation, right? And then we have a cart subsystem, right, where you check that whether the right item has been added to the cart, whether the customer has taken the items from the cart, right? And then and whether the right product has been added to the cart, right? And whether the address has been provided as well, right? So different things, right? And then we have a payment credit card interface, or a payment gateway, right, where user being asked to check enter the credentials, whether the credit card authentication with the third party to see whether the card is valid, right? Authentication is the information, right? And then you have different methods, like let's say it has 5-6 methods, right? Now for a user, right, do you think that user cares whether how this authentication is happening, whether the card is added to a list, or whether the card is doing some validation behind the scene, whether the product doing something else, right? I mean, as a user, I don't care, right? What I want to do, have the website or a consuming program to have pretty much limited functionality, right? And like number one, add an item to the cart, right? Right. Number two, right? Provide address, shipping address, right? And then check out and pay, right? All this is what I wanted, right? I don't care about all this, all this subsystem. So that's where the facade pattern, facade pattern. I've heard people calling facade as well. That's why I'm using this. I don't know, I mean, different people use this, but it's normally called as facade. So, I mean, when at different places of work, some people call facade, but depends, right? So it's normally used, pronounced as facade pattern. So, right, okay. So what we're gonna have? So we have different subsystems, right? P, C. This is for credit card, and this is for checkout, for instance, right? Imagine we have 3 subsystems. So what does the facade provide is a simple interface, right? So the user don't have to worry about underlying subsystems, right? Subsystems you can add more subsystems, right? All they want is a common interface where they expose the 3 methods, right? Add an item to a checkout, then provide an address, and then check out and pay, right? All they need is the 3 methods, right? They don't care about rest of the underlying subsystem. So that's where the facade comes in the picture. So that's pretty much the facade pattern is all about. I'll show you how I've implemented in the code. I've developed that in the code, just to save time, and I'll walk you through what I've done. It's a dummy code, just so, and I'll demonstrate it, okay? So let's jump into the code. I hope you understand the concept, right? It's just simplifying, the subsystem interface. You have many subsystems, right? And so Facade will give you a common interface so that the user don't have to worry about the subsystem functions or methods, right? User don't care whether whether your application is doing some kind of validation behind the scene. I mean, if I'm a user ordering a beer, why should I care how your credit card interacts with ANZ or ASB or Westpac or whatever, right? I mean, I don't care. I mean, what matters to me whether my card works and whether my items will be shipped on time, right? That's all I care. So that's exactly the calling program should be concerned about, right? So let's get into code side of it. Okay, so what I've done, I've created three subsystems. Like I created iProduct. I should have named it something else, but just to make it simple, it's an interface, not actual interface in the sense. So I named it as iProduct, which does two functionality, like if it says the check product exists, right, and get product ID. So right, so and then we have iCard, which does two things: add items to the card and then checkout, right? So and then we have iPay interface, which basically pays, does validation whether the card is valid. So this is just a basic code mock-up I've done, right? It's not talking to any external gateway, payment gateway. No, just to give you context, right? So we have three subsystems, right? And then we have iProduct, which does which when a user add an item to the cart, it does the validation first to see whether the product exists. If it exists, right, then it returns true, right? So if the product exists, then you can add an item to the cart. Once you can add the item to the cart, then the user can do a checkout. When they do checkout, they're normally being asked to provide an address, right? And once the checkout is done, they're asked to pay, right? So, and I've created this data load, which class, which basically adds the dummy data, right? It's like B1, B2. So I've used map, so I presume everyone knows what collections are about, right? So what I've done, right, I've added items like B1, B1, B2, B3, just for the sake of simplicity, right? So these are the products which is available. These are the products available in the brewery, right? But these are the products that's in stock at the point of time, right? Cool. So what I've done, so I'm actually in the first thing when a user so the get product ID, right? So it actually looks for the product name. Let's say a user selects a product, right? First of all, it checks whether the product exists, right? If it exists, then it checks whether it's in stock or not. If it's in stock, right, you can ready to add to the cart. And once it add to the cart, then the user can check out. And then once you do checkout, you can do the pay. So I've created this Facade Pattern here, Facade Pattern, sorry. So add item to the cart, right? This is the first function. So so when I'm exposing this interface, right, to the user, so the Facade Pattern method. So all I have is here is a three methods here, right? So add item to the cart. So behind the scene, so it's calling my iProduct class, and then it's checking whether the product exists. If the product exists, it adds item to the cart, or it will say no item found in the stock, please add another item, right? Cool. And then I'm doing a checkout. So when you're doing checkout, so I've been asked to provide an address, so you provide an address. So beyond the scene, I'm actually using this iCard class and the checkout method. And then final stage is to pay, where you've been asked to provide your credit card, credit date, the dates on the card, and the code, that's the code behind your card, and then the checkout ID, right? So that's pretty much you have to do. So so yeah, I mean, even you don't have to provide checkout ID, but just to make it simplified, just to give you context, right? So the way to call it, so I've just written some method here. So I've added item B1, B2, and then I've added and then I did a checkout. Then I expose this map. So this is the map. So I got this map here. So this is an iCard map, which actually which is the final stage before you check out. What I meant by that, it contains a list of products and an address, right? So that's all it does. So in this case, what I'm doing is I'm adding two items, B1 and B2. Then so user adds one item, second items, third items, right? And then you're ready to check out. When you're ready to check out, it asks you to enter your address, right? So the user is doing that. And then just to debug, I'm just looking at whether the checkout object actually contains the two items and address, right? And then I'm actually paying it, right? So I'll just demonstrate what happens. So if the card matches, right, it's just a dummy code, right? So for instance, when I'm paying, right, if the data matches, like the card and the credit date and the code, right, so you'll get a message, right, item shipped. Otherwise, you'll get a message called card decline, right? So let's run this to show how it looks like. Okay. So yeah, so you're gonna do debug here. So see item added. So debug. So this is the map. So you can see the item code 1 and 2, right? So and then the address. So the collection contains 2 items and item numbers, and then the address, right? So item numbers I'm getting from here, right? So so this is the item. So this is the item name, and this is the item code. I've hard coded it. I mean, just to give you context, so you can get it from a database. You can do whatever you want, right? So, so yeah, I got that information here, and then I go here, and then you see the item shipped, right? Now, what happens if the user, for whatever reason, right, muck up the credit card information, right? Instead of adding a right credit card, let's say the user entered the PIN wrong, right? Let's say 221. And then you execute it. Let's see what happens. So you will get the message, right? Card decline, right? So so you see how the Facade pattern has made the interface much easier, right? Because the user don't have to care about what's happening behind the scene, right? So this class, right, it exposes 3 methods. That's all the calling a consuming program has to worry about it. And think about a scenario, right, when you are consuming a third-party library, right? I've used Facade pattern a lot in C#. I've been used much in Apex. We use a lot of factory pattern in Apex, but C# I've used a lot of Facade pattern in the past, right? Because we have complex libraries, so I don't want that different subsystems to be exposed when we are giving to a third party to use our library. So I actually exposed few methods here, right? So that does the job. So I've done similar stuff when I was doing development in Delphi as well. Right. So yeah, I mean, this is very handy if you are looking to reduce the complexity. Then Facade pattern will do the job for you. Right. It's a part of structure pattern, as I said. Right. So as you can see from our current example, right, only the three methods being exposed. This is just for test. I mean, just to demonstrate whether the object contains the value or not. Right. So that's. So I hope you find this session valuable. I mean, if you're, you might get an scenario in your day-to-day integration or development where you might need to use this pattern, right? So yeah, feel free to read about it more and play around with it to see if it really works. You see that not every design pattern works for every solution, right? You need to find out, right? Not like factory pattern, for instance, does not work for every single solution out there. Similarly, a Facade pattern will not work for every problem out there, right? You need to figure out the right context where it fits in, right? Just because the pattern is available, it doesn't mean that you have to use it, right? Because the main the thing with the software development is that you need to simplify the process, right? You need to write a simple code so that the next developer can understand it. Anyone can make the code complex, right? I mean, anyone can over-engineer the stuff, which is not fun, right? At the end of the day, because if you write a code which is extremely difficult to debug for another developer, then I believe that's the return of investment on that piece of code is pretty much zero. Reason why is because it consumes more time to find a bug, to debug a bug, right? And then to add feature, right? The over-engineered code, it's just a sign of a programmer who thinks he or she is better than another one. My apologies if I'm using that terminology, but I've seen over-engineered code. It's extremely nightmare to debug. It doesn't make sense at the point of time because could have written in a very simple way, but for whatever reason, the programmer decided to over-engineer that. Oh, I thought, okay, these design patterns available on the shelf. Let's use it, even though you don't have to use it for that problem, right? So use it wisely wherever you wanted to use it. I'm not saying not to use it, but if you have a problem, something similar like this, then yeah, it makes sense to use it. But imagine using a factory pattern for this. It doesn't make sense, right? Right. So that's exactly what I wanted to say. So I'm gonna talk about a different pattern in the next session. We'll find out something which I've used and more useful. There are different patterns out there, right? I don't want to talk about every single one out there, right? So we're gonna talk about which is more often used and more often you might find the need for it, right? Cool. All right, that's all I wanted to talk about it today. Thank you very much. Adios and greetings from New Zealand. Bye bye.